Today we will start a new chapter, Synchronous Motor, and in this chapter we will understand the working of synchronous motor, its application, and how they are constructed. So before going to this chapter, let us understand this lecture is for diploma students and particularly for electrical branch students. Now let us go into the synchronous motor. So before starting this synchronous motor, let us understand what is the working principle behind this synchronous motor. So to know the working of synchronous motor, we have to understand the working of a motor. So every motor works on the principle of Faraday's laws. So what is Faraday's laws? So according to Faraday, whenever a current carrying conductor is placed inside a magnetic field, it experiences a torque. Now this torque is useful and we use this torque as a rotating thing. So this is a motor which is shown in your screen now. We have to put supply, that means three-phase supply, and we'll get the output in terms of mechanical output. That means we'll get rotation. Now how this will get rotated, let us understand. So basically it has a stator and it has a rotor. So there are two parts. So one is a stator part, the other part is the rotor part. In the stator part, we usually fed three-phase supply. Now student, as it is a three-phase machine, we have to put three-phase to this machine. That means the input should be three-phase now. Now this three-phase will produce a revolving flux, as we have already discussed in our earlier chapters of AC fundamentals. So this AC, what will it do? It will produce rotating or revolving flux around the stator and it will link to the rotor circuit. Now the rotor, which is not yet been excited, it has to be excited by DC source. The stator will be excited by AC source, the rotor will be excited by DC source, but it will not be excited simultaneously. First we have to excite the stator part. After exciting, it will produce revolving flux. Now if this revolving flux is produced, if we will put the DC supply on to the rotor side, it should rotate according to Faraday's laws of electromagnetic induction, but it will not rotate. Why? Because the inertia of the rotor is so high that it cannot respond to the quickly reversal of this magnetic field. Now to overcome, we make some modification. So what is that modification now and how it works, let us understand now. Now the first condition is that the stator is now supplied with three-phase supply. So consequently there will be a revolving flux produced. So as this revolving flux is produced now, we will rotate the rotor. Right? Now after rotating the rotor at about nearer to synchronous speed, this DC supply will be suddenly switched on. Now as it is been switched on, it will now lock with the stator teeth and to the rotor teeth. Now this motor will start running and now we can start, and this way we can start the synchronous machines. Now after running, this synchronous motor will run at a synchronous speed and if it will run only at synchronous speed, otherwise it will never run. So this motor have the speciality that either it runs at a synchronous speed or never at all. Now let us understand the theory what it has been written over here. The definition of synchronous motor states that an AC motor which is steady state, which is at steady state, rotation of the shaft is in synchronous with the frequency of applied current or voltage. The synchronous motor works as AC motor, but here the number of rotation made by the shaft is equal to the integer multiple of the frequency of the applied current. The synchronous motor does not rely on induction current for working, as we have discussed just a moment ago. So it does not depend upon the induction current for working. In this motor, unlike induction motor, multi-phase AC electromagnets are present on the stator. Right? The revolving flux which we have already stated. So this is multi-phase AC. Why? Because we have applied three-phase supply, which produces a rotating magnetic field. Hence, rotor is of permanent magnet. Why permanent magnet? Because we have applied DC source. If we have applied AC source, then it would have not been a permanent magnet. So in this case, a permanent magnet is produced. Why? Because DC source has been applied, which gets synchronized with the rotating magnetic field and rotates in synchronous to the frequency of current applied to it. Now further, the working principle, which we have already discussed. Let us understand by its theory. Working of synchronous motor depends on the interaction of magnetic field of the stator. Why? Because we have applied magnetic field to the, or we have supplied AC to the stator side with the magnetic field of the rotor. The stator contains 3-phase winding, as it is of 3-phase supply, and is supplied with 3-phase power. Thus, stator winding produces a 3-phased rotating magnetic field. Now the DC supply is given to the rotor. The rotor enters into the rotating magnetic field produced by the stator winding and rotates in synchronization. Now the speed of the motor depends upon the frequency of the supplied current. So it purely depends upon the speed and the frequency of the supplied current. Now we can see the relationship between the synchronous speed, frequency and poles. So Ns, which is abbreviated as synchronous speed, is given by 120 F by P or 60 F divided by P, whichever. But you should remember like this: Ns is equal to 120 F by P. Now, what is F? F is the frequency of the current and it is expressed in Hertz. Now, this P, this small p, stands for the total number of poles per phase. If the load greater than the breakdown load is applied, the motor gets desynchronized. What do you mean by desynchronized then? The speed is reduced to synchronous speed, can be called as desynchronized. The 3-phase stator winding gives the advantage of determining the direction of rotation. In case of single phase winding, it is not possible to derive the direction of rotation and the motor can start in either of the direction. To control the direction of rotation in the synchronous motor, starting arrangements are needed. Now, the starting method of synchronous motor, which we have already discussed, let us understand the theory. As we have already discussed the starting of the synchronous motor, what does the text says? Let us understand. The moment of inertia of the rotor stops the large size synchronous motor from self-starting. Otherwise, it should have started automatically. Because of its inertia only, it is not starting, as we have already discussed now. Now, because of this inertia of the rotor, it is not possible for the rotor to get synchronized with the stator magnetic field at the very instant power is applied. So some additional mechanism is required to help the rotor or to get synchronized. Induction winding is included in large motor which generate sufficient torque required for acceleration. Now for very large motor, we require pony motors are used. What is pony motor? Pony motor are nothing but to start the synchronous motor can be called as pony motors. Changing stator current frequency, electronically operated motors can accelerate even from 0 speed. So for very small motor, when the moment of inertia of the rotor and the mechanical load are designable, small, they can start without any starting method. Right? Now types of synchronous motor, we will just understand what are the different types available. So it are non-excited and direct current excited types. So you can see the diagrams of some synchronous permanent magnet synchronous motor. Here is an example of DC current excited motor which we will get, which we are observing in your screen now. Now the application of synchronous motor. Actually, these synchronous motor are widely used for power factor correction in industries where the power factor correction is hugely necessary. Now, they are used for precise and constant speed is required. Where constant speed and precise control are required, this kind of synchronous motor are used. Low power application of these motors include position mechanism or machines. These are also applied to robot actuators. Right? Ball mills, clock, record player, turntables also make use of synchronous motor. Beside this, motor are also used as servo motors and timing mechanism. These motors are available in fractional horseshoe size range in high power industrial range size. While used in high power industrial size, this motor performs two important functions. One is an efficient means of converting AC energy into mechanical energy, and the other is the power factor correction. This part is very important as far as your course is concerned. So for the synchronous motor, the main purpose which we use is for power factor corrector, which is application of servo motors you have come across. So this was all about synchronous motor. We will get in our next class, we will understand the different excitation levels, and you go through this video. Thank you for watching.